Okay, let's do our last few here with this quiz review. So we're picking and choosing now, okay, which of these functions we're going to do and which angles. So I'm going to keep repeating the same thing I've been saying in class, and that is find the angle first. Do you know where pi is on the unit circle? Okay, pi is over here, so we're using these coordinates. How do we evaluate cosine for an angle? We just copy and paste the x coordinate. That's it. -1. Done. That's it. Tangent. How do we execute tangent, or how do we evaluate tangent? First of all, find the angle. Where's pi over 4? Right here. Here are the coordinates. How do we evaluate tangent? We evaluate tangent by taking the y coordinate and putting it over the x coordinate. Now, let's take a minute and look at this because we've talked about this before, right? You want to do it the long way? Go for it. We take the top and we multiply by the reciprocal of the bottom, right? I've shown you this many times. We're taking the bottom, we're turning it over, and we're multiplying. So from here, the radical 2 over 2 becomes 2 over radical 2, and then we multiply. We can cross cancel on the diagonal. Anything that they have in common, these become 1s. These become 1s. 1 times 1 is 1. 1 times 1 is 1 for an overall value of +1. And like I said, think about this. Here's a fraction where what's on the top and what's on the bottom are identical. Anytime you have a fraction where the top and the bottom are the same, that equals 1. Okay? Now let's talk reciprocal functions. Cosecant of 7 pi over 6. Stop me if you've heard this before. When we're doing cosecant, okay, we're not going to do cosecant. We're going to do its sister function, sine, first. So we're going to figure out what the sine of 7 pi over 6 is. How do we do that? We find the angle, right? Where's 7 pi over 6? Is it on the unit circle? It is. It's right here. So we're using these coordinates. And how do we evaluate sine? We evaluate sine by identifying the y coordinate. So the sine of 7 pi over 6 is -1/2, which means the cosecant of 7 pi over 6 is the reciprocal of that. There's a reason cosecant is called a reciprocal function, because we find sine first and then we flip it over. Okay? Secant is not related to sine. Secant is related to cosine. Right? One way I always kept track of this in terms of what are the sister functions. There's two functions that start with a C, cosine and cosecant, both start with a C. They're not related. Oh, well, sorry, cotangent too, right? So 3. But cotangent has the word tangent actually in its name. So that's a pretty obvious relation. But when you talk cosecant and cosine, they both start with a C. They're not related in any way. Cosecant is related to sine. And the secant function, which starts with an S, is related to cosine. So the C and the S functions are related separately. C to S, C to S. That's always one way that I kept it straight in my own head. So when we're evaluating secant, we do cosine. Cosine for an angle, find the angle. The angle is 5 pi over 6, which means we're using these coordinates. The cosine of 5 pi over 6 is the x coordinate. So the cosine of 5 pi over 6 is negative radical 3 over 2, which means the secant is -2 over radical 3. And then we rationalize the denominator. So we end up with -2 over radical, 2 radical 3 over 3. All right. Now, sine of 13 pi over 3. Oops, that's me. Let's clear this up. No. Uh-oh. There we go. Sorry. 13 pi over 3. Sorry, where were we? 13 pi over 3. Find the angle. Not here, right? We've talked about the pi over 3's before. Here's a pi over 3 angle. Here's a pi over 3 angle. Here's a pi over 3 angle. And here's a pi over 3 angle. There's 60-degree rotations around the unit circle. So if you want to know where 13 pi over 3 is, we have two options. Option number one, count the pi over 3 rotations. So if we start here in the positive direction and we rotate this way, that's 1 pi over 3. If we keep rotating over to here, that's 2 pi over 3. That's a 60-degree rotation. Do another 60-degree rotation. That's 3 pi over 3. Down to here is 4 pi over 3. All the way over to here is 5 pi over 3. And all the way back up is 6 pi over 3. Now keep counting. Now that we have these tick marks, so this was 6 pi right here, 7, 8, 9, 10, 11, 12, 13. So 13 pi over 3 is the same as pi over 3. Okay, so for evaluating sine, now that we know that 13 pi over 3 and 1 pi over 3, 13 pi over 3 and 1 pi over 3 are essentially the same because they're coterminal, we're just going to do the sine of pi over 3, which is the y coordinate. That's it. Radical 3 over 2. Okay, the alternative for that is taking 13 pi over 3 and coming up with a coterminal angle for it by subtracting 2 pi. And we've talked about this at length as well. 2 pi in terms of thirds is 6 pi over 3. If we subtract that, we get 7 pi over 3. So 7 pi over 3 and 13 pi over 3 are coterminal. But 7 pi over 3 isn't a number that I see on the unit circle. So I can subtract 6 pi over 3 again. That's a different method to getting that same angle. You can subtract 2 pi to get the coterminal angle, or you can count the tick marks around the circle. Okay. Last but not least, we have the cotangent of 0. Okay. Find the angle. Here's the 0 radian angle. Here are the coordinates. Now, cotangent is the reciprocal of tangent, but we don't need to find tangent to do cotangent because cotangent is the x coordinate over the y coordinate. And the x coordinate is 1, the y coordinate is 0. This is bad. We can't have 0 in the denominator ever, okay? So this overall value is what we call undefined, right? This will happen from time to time. You will get 0 in the denominator, right? When that happens, we just have to say that the value is undefined, all right?